CNNBC recently reported that the mean annual cost of auto insurance is $1,006. Assume the standard deviation is $260. You take a simple random sample of 93 auto insurance policies. Find the probability that a single randomly selected value is at least $970. All right, so I'm looking for a probability, and I am trying to find the probability that it is at least $970. Now, they haven't told us that the distribution is normal, but I sort of understand why and how this problem is set up. We're just going to assume that it's normally distributed so we can work the problem through. So that it's normally distributed, we could draw a distribution, the mean of which is $1,006, and the standard deviation is $260. Now, the mean is located right in the center. Then we have 970 here. Then this is shaded to the right. So we would find this probability by using Normalcdf. It takes 4 inputs. The lower bound of our shaded region, the upper bound of our shaded region, which infinity is not a key, so just e to the 99 means 1 times 10 to the 99th power. Then I give it the mean and the standard deviation. Now, using the calculator to get my result, I can do second distributions, Normalcdf, and just type in the values as I see them. To get the E, you do second and comma, then put 99 after that, 1006, and 260. So that gives me 0.5551. So that's my probability there. Now, we want to contrast this with finding the probability that a sample of size n equals 93 is selected that has a mean that's at least $970. So because we're working with a sample, that changes things. One thing that changes is that we are now using a sampling distribution. In a sampling distribution, we no longer have to make a broad assumption that this data is normal. We can now say for certain that the sampling distribution is normal, because the sampling distribution is normal whenever you're drawing sample sizes that are bigger than 30 from it. Not much changes in the way we solve the problem, but we do have to take into account what happens to the mean and standard deviation. The mean of the sampling distribution is the same as the mean of the population. The standard deviation of the sampling distribution is the original population standard deviation divided by the square root of 93. So when I go to answer this question, which we still have the same mean, we still have the same value in question, which is 970, we're still shading to the right, we're just simply using a different standard deviation. Let's see how that affects our answer. So we use Normalcdf to get the area under the curve. The shaded region begins at 970, goes to positive infinity. The mean is 1006, and the standard deviation is 260 divided by square root of 93. And if we use the calculator to get the answer, and some of you may be seeing menus when you use Normalcdf. That's perfectly okay. You have one of the later model TI-84s, and it looks like this. So instead of typing in a comma-separated list for the information, you're actually just typing in the values in a menu. And that helps you remember what needs to be put into the function. And it also makes it a little bit cleaner to type it in, because when you get down to putting in the standard deviation, it's scrolled off screen quite a bit in the other mode. And so it's hard to know what you've actually typed in. So it's a little bit nicer, but it's not necessary. So either way you go, you still get 0.9091. And just so you can see it, anyone that doesn't have the menus, let me do that for you otherwise. So let me turn those back off. Now when I do the Normalcdf, and I'm just typing in things, so 970, comma, second comma gives me the E and then 99, 1006, comma, 260 divided by the square root of 93. And there you get the same result.